Sometimes it's useful to be able to predict the position of a moving object at some time in the future. In this video, we will introduce the second of our kinematic equations, which allows us to do precisely that, to determine the position of an object at some time in the future if we know something about its current motion. We begin with the definition of average velocity, being the change in position with respect to time. This equation can be arranged or transposed to give an equation for the final displacement. The average velocity is the mean value between the initial velocity and the final velocity, and is calculated by taking the sum of the initial and final velocity divided by 2. Thus, we can substitute the average velocity equation into our motion equation to give us an equation that can determine the final position of the motion at any time if we know the initial position and the velocity as well as the final velocity. This equation can also be written in the following way, or like this, where the difference between the final and initial position is represented by the displacement. Let's consider an example. A rescue helicopter is hovering above a broken down boat. It drops a small emergency kit down to the boat. The kit takes 2 seconds to fall to the water below it. So let's list all of the facts about the problem. We have time being 2 seconds, initial velocity being 0, acceleration being 9.8 meters per second squared. In the last video, we determined that the velocity that the kit hits the ground, or the final velocity, was 20 meters per second. We also defined the downward direction as being positive, and we're looking for displacement. Now let's apply the information we have to the equation. Notice that when we use this equation, we do not need to know the acceleration because we have already used acceleration to calculate the final velocity in the previous video. So our equation becomes half of 20 meters per second times 2 seconds, or 20 meters. Notice that the answer is positive, indicating that the final position is below the helicopter. This is consistent with our direction being positive downwards. The 2012 Ford Mustang Boss 302 can go from 0 to 100 km per hour in 4.5 seconds. How much distance does it cover during this time? The Mustang takes 277 meters to decelerate from its maximum speed of 259 km per hour to a complete stop without skidding. How long does it take to do this? Our second equation of motion defines the final position being equal to the initial position plus the product of the average velocity with time. The average velocity is the sum of the initial and final velocities divided by 2.